Hi everybody. As we saw in class, when we find the antiderivative of f prime of x, we get this expression. The antiderivative of f prime of x equals f of x plus c. And we showed that the antiderivative is unique in the sense that if two functions, f and g, are both antiderivatives of the same derivative, they have to be the same function within a constant c. We express this idea in math like this. If f prime of x equals g prime of x on the closed interval a to b, then f of x equals g of x plus c on that same interval. Our goal for this video is to find the constant c, which is called the constant of integration. First, let's practice finding a couple of antiderivatives. We're going to use these results later on in the video, so try to remember them. Our first problem is, find the antiderivative of 3x squared dx. And our solution is to scan down the list of derivative rules, looking for an exact match to our integrand. Oh look, the first one is an exact match with n equals 3. As soon as we have found an exact match, we can then write our solution. The antiderivative of 3x squared dx is x cubed plus c. Let's do another one. Consider the problem, the antiderivative of 1 over the square root of the quantity 1 minus x squared dx. Our solution method is exactly the same. We scan down the derivative rules, looking for an exact match for our integrand. And we find one. Towards the bottom of the page, we have the derivative of arcsine x is 1 over the square root of quantity 1 minus x squared. So we can immediately write our solution. The antiderivative of 1 over square root quantity 1 minus x squared dx equals the arcsine of x plus c. So how can we find the value of c? Let's go back to our first antiderivative. The antiderivative of 3x squared dx equals x cubed plus c. This graph shows two different antiderivatives formed by choosing two different values of c. Take a moment to check that both of these functions, f1 and f2, have the correct derivative. I'll wait while you check that. So you can see that both of them are correct antiderivatives, but the difference is the constant c. And the effect of that constant c is to shift the graph up or down. This animation illustrates the effect of c in a fun way. Take a look at the graph and see what it's doing as the value of c changes. As c increases, the graph moves up. You can see it most clearly by watching the y-intercept of the graph as c changes in value. Consider the problem, find a function f of x such that f prime of x equals 3x squared and f of 1 equals 4. The equation f of 1 equals 4 is called a condition for f of x. Now we already know that f of x has to equal x cubed plus c. If we take a look at the animated graph from the previous page, we can see that adjusting the value of c moves the graph up or down. Our condition means the same as saying that our curve has to go through the point 1, 4. So, all we need to do is to find the value of c that moves our curve up until it goes through the point 1, 4. Looking at the graph, you can see that happens approximately when c is equal to 3. Even better is an algebraic solution. We start like this. First we perform the antiderivative. F of x equals the antiderivative of 3x squared dx, which is x cubed plus c. Then we apply the condition, f of 1 equals 4, which means that 1 cubed plus c is equal to 4. Using a little bit of algebra, we solve for c and get c equals 3, and we assemble our solution, f of x equals x cubed plus 3. Let's perform the same algebraic method with another problem. Find a function g of x such that g prime of x equals 1 over square root quantity 1 minus x squared and g of 1/2 equals 3. Take a moment to identify the condition for g. That's right, g of 1/2 equals 3 is the condition. Now you remember from our previous work that g of x is equal to the antiderivative of 1 over square root quantity 1 minus x squared dx, which is equal to arcsine of x plus c. Now we apply the condition, g of 1/2 equals 3, which equals, therefore, arcsine of 1/2 plus c. Using a little bit of algebra, we see that c is equal to 3 minus arcsine of 1/2. From your unit circle, you remember that's the same as 3 minus pi over 6, and the calculator can tell you that this is approximately 2.4764. You might see the solution in any one of those three forms. The middle one is going to be the most common. Putting it all together, we say that g of x equals arcsine of x plus 3 minus pi over 6. Okay, it's time to practice. I'm going to put up 3 different problems. After each problem, I'll give you a moment to pause the video. While the video is paused, you can work out your solution and then hit play again to check your solution. If at any point you're confused, you can start the video over and take a look at the explanation again. Here is the first problem. And the second problem. And the third. Let's recap everything. When we are given f prime of x and a condition, and we need to find f of x, first we find an antiderivative, then we apply our condition, and that gives us our solution. I'll see you in class.